Hey, we're going to learn about how to check if two graphs are either parallel or perpendicular today. You've probably gone over that in some other math classes, but I'm going to show you how we can check that on here. So and we're just going to hop in again onto Desmos, and I'll put some examples up there as well so that we can have those worked out to show that two graphs are parallel. If two lines are parallel, that means that their lines, they follow each other into the same direction, and they never cross. In other words, a lot of people say they just go on and on forever, never quite going. And how we check that in an equation, if I just go in here and put y equals mx plus b, here's our line again, y controlling the slope, b controlling the y-intercept. To make an equation that is parallel to that, we just need to make sure that the slope is the same. So if I use the same letter here, m, x, and then a different y-intercept, maybe I'll just put a c for a y-intercept, it doesn't matter. Now this purple line and red line are going to be parallel no matter what I do, right? Because the y-intercept is the same, that's just going to space them out, but that's not what we're kind of worried about. We're checking the slope is going to control on both, so they'll always stay parallel here because this slope is exactly the same in both. They're both m. So in order for lines to be parallel, we check their slopes. If their slopes are the same, we got a parallel line. To check that something is perpendicular, in order to do that, it's a little bit more refined, kind of the same thing. We still check their slope. So again, maybe on this one, I'll just make a different slope. I'm going to call it M1. We don't need those parallel lines. M1, X plus some other, I'm just going to put K. That doesn't really matter. Again, this one got my slope, got my y-intercept on there. To check if something is going to be perpendicular, we need to check that the slope is both a reciprocal and it is negative. One of them is positive, one of them is negative, right? So we call that a negative reciprocal. Reciprocal meaning we flip the number over. So here the slope is just m1. So I'm just going to flip it over, 1 over m1, right? I'm just going to flip that to the denominator, put my x value in front, then plus some other y-intercept. Maybe I'll use h this time. So again, these two lines right now, they're a little bit parallel because what I forgot, and you're saying, oh, man, they're not quite perpendicular, right? They'll cross, right? They do this kind of fancy dance here. But to make them perpendicular, I have to remember to make it a negative slope. So I'm going to put a negative right there. And now that makes sure that those are perpendicular. No matter how I change the slope around, they're always perpendicular. Now this intersection point moves. Sure, I don't know quite where they're going to run into each other, but I do know that they're perpendicular. Perpendicular does not mean they just run into each other. It means they run into each other and they are 90 degrees, right? It is a perfect right angle wherever they hit. That is when things are perpendicular, is we use a negative reciprocal. So we can check the slope to see whether they're parallel or whether they are perpendicular lines. So a couple examples that we'll do on here. We'll get rid of those. Here's our first example on this one. And go back up here. We're going to check, are these lines perpendicular or possibly parallel, right? So in here, what I might do just to check right away is I might just take these two here, type them right into here. So here's example 1. I've put them in already. So we can type those in and just take a look and see, are those perpendicular? It sure looks like they are, right? But again, we're using this to kind of get an idea. Maybe they should be perpendicular. They're definitely not parallel, but we want to make sure. How do we check that? And there are 2 ways to check if things are parallel, perpendicular. Way number 1, that's the more definitive ways. We can check their slopes. Now, way number 2 is you can check their, what I call their pseudo slopes, right? It's quicker to check their pseudo slopes, but we kind of lose a little bit of understanding. So on option 1, to check their slopes, and the easiest way to do that, solve the equation for y and just grab the slope right from there. So like in this one here, I'm going to work that out on here. If we solve this for y, we would add the 2x over, so we would have 5y equals 2x plus 20, because we would add that 2x over, and then we would have to divide everything by 5. So in here, we'd have y equals, well, we're going to have 2x over 5 and then plus 20 over 5. And I'm just going to leave it as 20 over 5. I understand that's 4, but when we're checking if things are parallel or perpendicular, the y-intercept doesn't matter. Only the slope does. So that's the only thing we're going to care about there. Same thing over here. Subtract the 9x over. So we got far y equals, I suppose, negative 9x in this case, plus our 8. And then we would go ahead and take everything and divide by 4. So y equals negative 9. And you can, again, it doesn't really matter if we put the x in front or on the numerator. It's the same thing. And then plus 8 divided by 4 being 2, or you could put that as a fraction as well. So now all we need to do is check, are their slopes opposite reciprocals of each other? And so in here, when we go ahead and check that, the slope here is 2/5 on that one. So let me point that out to you. 2/5 is the slope here. The slope here is negative 9 over 4. So the reciprocal of this would be 5 over 2, which is not the same as 9 over 4. Now, I know some people might be saying, well, hey, it looks pretty close on that graph. Why do they look so close to each other? And the reason that they look so close to each other is because 5 over 2, right? If we look at 5 over 2 and kind of go from there, 5 over 2 is pretty darn close, right? Let's take this here. So we'll just put this as a fraction. 5 over 2 is actually the same fraction. If we update it a little bit so they have the same denominator, is 10 over 4, right? Which is pretty darn close to 9 over 4, right? I get that this one's negative. So since, this slope here, the reciprocal of this slope is fairly close to this one, when we go to graph it, it looks almost perpendicular. But you notice here, it's not exactly 90 degrees in this case because they are not opposite reciprocals. So when I flip this one over, it does not match this one at all. All right, it's 5 over 2 and 9 over 4. So these are not perpendicular. That would be our conclusion, right? Because we check those slopes, they're not the same, right? We could even say a little bit more with our reasoning. 5 over 2 is not equal to, let's put that, 9 over 4, right? They're not the same thing when we flip them over, and one of them is not, one's positive, one's negative. That works, but isn't. Another way that we could check that, this one goes a little bit faster, although we lose a little bit of understanding on that slopes. But if you get that, we're kind of checking the slope, we can do a quick check on that. So I put a thing down here. I'm going to show you how we do that. So if we want to check whether things are perpendicular, we multiply parallel. Which I mean by that is we multiply the coefficients in a sort of a vertical direction. We multiply the x coefficients and multiply the y coefficients and see if they're negatives of each other, right? So like in this case here, what we would do is we would take negative 2 times 9, and then we would also take 5 times 4 and see if those are negatives of each other. So in this case here, if we take negative 2 times 9, we get negative 18, and then we would also check to see 5 times 4, and that's 20. And these are close. Again, here, we get another value that is close, but, not perpendicular. So close, but not perpendicular. So if these two had ended up being like negative 20 and positive 20, then we would know, yes, that they are perpendicular. But in this case, they are not the same thing. So that's one way. It's quicker, but again, we sort of lose that understanding. But what we're doing is checking those slopes. And the reason that sort of works out, we can go in here. Let me get rid of these. Our pseudo slope in here, the reason that works if I just put a line in is because the C value, we don't really care about that. All that does is move the graph up and down. It doesn't actually turn. It doesn't change the slope. But A and B both affect the slope of that. So B value, affects, kind of the turning here on the x-axis. And this one, also changes it. So A and B affect the slope, and that's kind of what we're doing. We're checking those coefficients in front on how they do that. And since to check Perpendicular lines, we end up flipping the x and y value. We just multiply along these. It's kind of a little bit different. So that's kind of our option there, right? Close but not perpendicular. So our one here that we're going to check as well, if they're parallel or perpendicular, right? If I wanted to check this, and we'll go ahead and we'll type it into Desmos in a minute. But there again, you have two options, right? You can either just solve for their slope and check that, or we can do their pseudo slope, which sometimes is a little bit faster. So what I'm going to do first is just check their pseudo slope. So way one, if I want to check if they're perpendicular, right? I'm going to check their sort of same direction, right? Here I'd go 6 times 18, right? And I would check that on there. Off the top of my head, I'm not quite sure what that is. We would want to make sure that we go here. So I'm just going to go into this one and do 6 times 18, and we'll get there. That's 108. So 108. And then if I check the other direction, you know, we would check 4 times 12. It equals, and I know I put a different multiply sign in there. It's the same type of thing. 4 times 12 is 48. So those are definitely not perpendicular because, again, they should have come out to be the same thing, one positive, one negative. So not perpendicular. Not perpendicular, right? That's how I'm going to abbreviate that. But now if we want to check if they're parallel, right? Check if the things are parallel. Well, then we check the cross multiply. We check the cross multiplying. So here we would do 6 times 12 and see what that's equal to. And we would also do 4 times 18 and check what that is equal to. In fact, if we do these here, 6 times 12 is 72 in that case. And in fact, if we check this, 4 times 8 is also 72. So since these come out, their pseudo slopes come out to be the same, we would say they are parallel, right? No, if I could actually, yeah. Yeah, that they are parallel, so we can check those pseudo slopes there. And if you don't like checking that stuff, you can always solve this for y. In this case, this one, I solved this for y. I'll put a little space in there so we know that that's the same equation. We would subtract the 6x and then divide by 4. So we would have negative 6 divided by 4x plus our 19 over 6, right? I'm just going to write that normally. And so there we would. And then in this one too, we would do the same thing. We would solve for y. We'd say y equals subtract the 18, divide by 12. So let me put that fraction, negative 18 over 12, x plus, well, it doesn't really matter, but I'll put it there, 3 over 18. This part's not really mattering on whether they're parallel or not. And then we would see, are their slopes the same thing? And in fact, this fraction becomes negative 3 over 2. This fraction becomes negative 3 over 2 if we reduce it. So their slopes are the same in this case, both negative 3 over 2, so they are parallel. So in that case, we would know that they're parallel also. And we could always check that too. We could hop back here, and so I'm going to turn this one off. And if we check our example 2 and I type both of those in there, we can see that, yep, those do look fairly parallel. And in fact, we showed here that they are. So that's how you can check whether lines are parallel or whether they're perpendicular. I don't care which option you use. This one probably makes a little more sense. This one, you know, is a way that does work out, but, you know, you sort of lose some of that understanding of why it works so well. All right, good luck.